So what does it mean to say you want to prove? Proof is all about saying that something is true. Proof is all about showing that something is true. Is that clear?
Yes, sir.
So let's see some useful facts. Improve questions. Number one, any even number can be written as 2n. Any even number can be written as 2n, where n equals 1, 2, 3, and so on. So something. So any even number can be written as 2n in a generalized form, where n is any integer, any positive integer. So you see that when you substitute different values of n, positive value, the numbers you are going to obtain will always be an even number. Even number are numbers that are divisible by 2. Is that clear?
Yes, sir.
Number 2, any odd number can be written as 2n plus 1 or 2n minus 1. Number three, consecutive integers can be written as n n plus 1, n plus 2, n plus 3, n plus 4, and so on. Or as n minus 1, n, let me start from n minus 3 or n minus 2, so that you'll be able to understand something there. Let's say n minus 2, n minus 1, n, n plus 1, n plus 2, and so on. Now, in this context, the second consecutive numbers has captured negative integers. For instance, now, you know that n will always start from 1. So if you substitute 1 for n in n minus 2, you have minus 1. Then the next one will be 0. The next one will be 1. The next one will be 2. Is that clear?
Listen.
So when you see numbers in this arrangement, this is a generalized way of expressing a consecutive number or integers. Number 4, consecutive even numbers. Can be written as two n plus 2, 2n plus 4, and so on. That's consecutive even numbers. So if n is 1, for instance, you see that the first number is going to be 2, the second is going to be 4, the third is going to be 6. So you have 2, 4, 6, and it will follow that order. If n is 2, the first number will be 4, the second will be 6, and the third will be 8, and it will follow that order. Consecutive. Consecutive means one after the other. Is that clear?
Yeah.
Okay. So number 5, Consecutive odd numbers are 2n plus 1, 2n plus 3, 2n plus 5, and it continues like that. Is that clear? But there's one thing I want you to take note of. In the consecutive even numbers, you can see that we have made use of the generalized way of writing even number, which is 2n. Now, when we want to have odd numbers, we say 2n plus 1 or 2n minus 1. Don't forget, 1 is odd. Odd numbers are numbers that are not divisible by 1, by 2. So if 1 is odd, so 2n, which is even, that means we are using the fact that even plus odd is odd. Is that clear? Even number plus odd number is odd number. And if you look at the consecutive even numbers, we have
Mm-hmm.
used 2n, 2n plus 2, 2n plus 4, and so on. So meaning that even plus even is even. And for the consecutive odd, we have used 2n plus 1, 2n plus 3, 2n plus 5. So if you look at 1, 3, 5, they are odd numbers being added to even number that is 2n. So these are facts that will help you when you want to prove some other identities or claim, as the case may be. So take note of this. We'll be using them as we progress. So when you're done writing, let me know, please.
All right. I'm done.
Okay. So let's see some proof. So example 1. Prove that the sum of three consecutive integers is a multiple of 3. Prove that the sum of 3 consecutive integers is a multiple of 3. If you are done writing the question, let me know.
I'm done.
You are done.
Yeah.
Okay. Well, have you solved it? Is that what you are saying?
Hmm?
You are done writing the question or the solution.
And the question.
Okay. So let's quickly do that together. So now, since the question demanded for 3 consecutive integers, so the first thing you will do is say let the integers be n, n plus 1, and n plus 2. N plus 1, n plus 2. Now, the sum of the 3 integers, n plus n plus 1 plus n plus 2. So that will now be n plus n plus n, 3n. Then 1 plus 2, 3. Now, you will see that 3 is common. So I can factor out 3. If you factor out 3, then you have n plus 1 remaining. So you can see that we've been able to express it as multiple of 3 since we have 3 factored out. And don't forget that n plus 1 is what? Integer. Is one of the integers that we have assumed here. So you can now conclude that hence sum of three consecutive integer is a multiple of 3. So write that. When you are done, let me know. Then we'll now see alternative way of doing it again. When you are through, let me know.
I'm done.
Okay. Now let's see alternative way of doing this same problem. So I can say that let the consecutive integers be n minus 1, n, n plus 1. So the sum now will now be the addition of the three. N minus 1 plus n plus n plus 1. So n plus n plus n by like terms will give you 3n. Then minus 1 will take care of plus 1. So you have 3n, which is multiple of 3. Do you get that now? So you now make the same conclusion. Hence, sum of three consecutive integers is a multiple of 3. Is that clear? Are you done writing that? Hello, Mr. Day.
So,
Are you done writing this alternative?
I'm finished.
Okay.
Done.
Okay. So let's start another one. This one says proof that the sum of two consecutive square numbers prove that the sum of two consecutive square numbers is always odd. Prove that the sum of two consecutive square numbers is always odd. I want you to attempt this. Let me see how you are going to fare. Are you making progress?
Yes, sir.
Okay.
I don't know what to do.
Oh, and it's straightforward. All right.
Mhm.
So this is how to go about it. Oh, we have let me finish the meeting, then you log in immediately. We have 5 minutes, otherwise we'll be cut off. Do you get that now?
Yes, sir.
So I will end, then you join immediately.